welcome to the channel. The purpose of channel is to facilitate students in learning physics at their convenience. It is a class without a classroom, so learn physics at your convenience. Let us start our today's lesson. Our topic is capacitors in parallel. Students, in electrical circuits, sometimes we need more than one capacitors. There are two ways of connecting capacitors in a circuit. One is called series and other is called parallel. Today we will discuss how the capacitors are connected in parallel. Look at this diagram. If there are three capacitors with capacitances C1, C2 and C3, if they are joined in a circuit such that left plates of all the capacitors are connected to a single point and right plates of all the capacitors are connected to another single point, and when a voltage source V or a battery of voltage V is connected across these points, all the capacitors are directly connected with battery now, and all of them will be charged according to their capacitances. Let Q1, Q2 and Q3 are the charges on these capacitors. Then the total charge on the circuit will be equal to the sum of all these charges on these capacitors. That is, Q for total charge is equals to charge on first capacitor plus charge on second plus charge on third. Now students, from the equation of capacitor that relates voltage, charge and capacitance, we know Q equals to CV, means charge on the plate of capacitor is the product of its capacitance multiplied by the potential difference across it. Here we know that the voltages across all the capacitors are same, and that is equal to voltage of the source. So we can also write that V equals to V1 equals to V2 equals to V3. So replacing the value of Q here in this equation, we get this form. C equivalent into V means total charge equals to the product of total capacitance multiplied by total voltage or voltage of the source. C equivalent V is equals to C1V. C1 capacitance of the first capacitor, V is the voltage across it, plus C2V instead of Q2. C2V, C2 is the capacitance of second capacitor and V is voltage across it. Similarly, C3V for Q3. C3 is the capacitance of third capacitor and V is voltage across it. Now students, on the right hand side, taking V common, we get the equation like this. C equivalent into V is equals to V into C1 plus C2 plus C3. V on the right side will be cancelled with the V on the left side, and we get this equation. C equivalent is equals to C1 plus C2 plus C3. It is the equation that we use for finding the total capacitance of a circuit when different capacitors are connected in parallel. So this equation shows that in parallel combination the total capacitance increases. The total capacitance is more than the largest capacitor connected in the circuit. So if we are having some capacitors of low value and we need a capacitance of a capacitor of higher value, we will connect them in parallel. This is all about the parallel combination of capacitors. I hope it is clear. Students, thank you for sparing your time to watch this short video. If you liked it, don't forget to subscribe the channel. Take care of you. Goodbye.